Okay, so in this video I want to talk about the weighted summer, which is an operational amplifier circuit used to sum voltages. So let's suppose that we have an operational amplifier here. This is the minus input, this is the plus input, this is the output. We call this V0, and this is taken, of course, with respect to ground. This is plus, this is minus. Then we put a feedback resistor from the output going back into the negative input. We ground the positive input. Here on the, this is where the action is, on the negative side. So on the negative side we add a few resistors. So we connect a few resistors on that point. So let's connect 3 of them, and we input voltages at these ends here, V1, V2 and V3. Of course we're also taken with respect to ground. Let's call this resistor R1, R2, R3. So we have a junction point here. Now this V plus input is at 0 volts, and because of the virtual ground assumption, the V minus input is also at 0 volts, and this is why operational amplifiers are so useful, and that's because of the virtual ground method. If the plus input is at 0 volts, the minus input will also be at 0 volts under negative feedback. So let's call this resistor here just R. Now there will be a current flowing into the R resistor. Let's call that current I. There is no current flowing into the negative input because that has infinite input impedance. So also there is a current I1 here, there is a current I2 here, and a current I3 here. So what we do is I1, I2 and I3, the currents, they're going to be added up, and their result is going to be the current I. So we can write down that I is equal to the sum of I1, I2 and I3. And now we can calculate I1 to be equal to V1 over R1. This is Ohm's law. So I2 is equal to V2 over R2, and I3 is V3 over R3. Now the second thing we have to do is we have to find the voltage V0. Now V0 is equal to, now because the current is flowing from this side to this side, we are assuming it does, then the voltage here, this node, is considered to be higher than the voltage at the V0 node. So because of that we follow the current convention. So V0 will be equal to this voltage, which is 0 volts, minus the drop across resistor R, and the drop across resistor I is simply the current I times R itself. So V0 is equal to minus I times the resistor R. Now we know that I is the sum, again I is the sum of I1 plus I2 plus I3, and so V0 is equal to R minus R times I, and let's write the components of the currents in terms of their voltages. So that's V1 over R1 plus V2 over R2 plus V3 over R3, and so we can rewrite V0 to be equal to minus R V1 over R1 plus minus R V2 over R2 minus R V3 over R3. So we see that the output voltage V0 is equal to the negative of the sum, the weighted sum of V1, V2 and V3, and this is called the weighted summer. the weighted summer circuit.